let's try this question. You want to solve this using matrices. So you want to imagine that this is like 1, 1, and then 0, x3, even though there's no x3 there. You want to think about this as 1, x1 plus 0, x2, and minus 2, x3. You want to think about these missing x3 and x2 as having coefficient 0. Now, why do we want that? That's because the idea of matrices was to get rid of these x1s, x2s, and x3s and write only the numbers, called the augmented matrix. So you put 1, 1, 0, and then 4. And then this one, 1, 0, negative 2, and 5. And the last one, 3, 2, negative 2, and 1. Sometimes people draw a dotted line here just to remind ourselves where the equal sign is. Some textbooks don't care. Well, you just have to know where it is. Okay? All right, so we learned last time that there are some basic moves that you can do, which is you can swap two sides. You can take any multiple of one and add to the other, or you can multiply any non-zero number to any of the rows. And by doing that, I explained how you can solve this. Right? So let's try to apply that reasoning to here. So first of all, I think I want to take the first row, multiply by negative 1, add to 0. Because you remember what our goal is? Our goal is to make echelon forms, right? Row-reduced echelon forms. And row-reduced echelon forms means you want something like 1, 1, 1, and 0 everywhere. So your first goal is to make 1 here. It's already 1, so that's good for us. But you need to get rid of those as 0. You need zeros here and there. Once you have those, then your next goal is to do this one and make 0, 0. So just be mindful of the order that you want the numbers to be. So first goal is to make this as 1. Next goal is to make these two as 0. The next one is to make this one as 1. The next goal is to make these as 0, and then so on and so on. Okay? So we're going to go for that plan. And I think the right way to do this is to take negative of the first row, add to the second row, and put that result in the second row. That's going to get rid of this. Right? On the other hand, if I take negative 3 times the row 1 and add it to row 3, and then make it replace R3, that will also make this as 0. So we make 1, 1, 0, 4. That we didn't touch at all. And then negative 1. So you're basically doing this minus this, and the result goes here, right? So 1 minus 1 is 0. 0 minus 1 is negative 1. And then you have negative 2. And then 5 minus 4 is 1. And then 3 times this is being subtracted from here. So you get 0. 3 times 1 is 3. Subtracted from 2 is negative 1. Negative 2. And then 4 times 3 is 12. Subtract that from 1 is negative 11. So I got the first column work. Okay. All right. Now, what do you go for? What's the next thing?
You've got negative 1.
This negative 1 has to be
Positive.
positive 1. How do you make that happen? You multiply the second row by negative 1. Right? So we multiply the second row by negative 1. So you have negative 1 times the second row.
And then add it to row 3?
No, you just replace. You're just replacing the second row by. So these are two different moves. So one allowed move is you can take any multiple of one row and add it to another. Another one that you're allowed to do is you can just simply multiply a non-zero number to any row. Yes?
So instead of multiplying times negative 1 and making it positive right now, can we just add row 2 to row 1 and that gets rid of the 1 on top of negative 1?
Yeah. So the question is, can we just add this to this so that you make this as 0? That's possible too. But I usually want to go by this system where you do 1, 0, 0, and then 1, 0, 0, and then 1, 0, 0. That's the way I want to go. Okay? All right, so you have 1, 1, 0, 4, 0, negative 1, negative, oh, positive 1, positive 2, negative 1, and then 0, negative 1, negative 2, negative 11, and I guess the second row has to be, negative of the second row has to be added to the first row, replacing row 1. And then row 2 should be added to row 3, replacing row 3. And the result is that you have 1, 0, negative 2, positive 5 if you subtract this off from here. Or you could have added here. Okay, and then 0, 1, 2, negative 1, we don't do anything. And then this one, you have 0. If you simply add these two, it's 0, 0, and then negative 12. You get that. And then you run into trouble because now you have a 0 here, right? You have a 0. Something's not good. If this is 0, there's no way to change these. These are stuck. Okay. These are somewhat stuck, right? On the other hand, if the question was simply make this into reduced row echelon form, so here are two different goals here. If the question was simply solve this equation, right, then you can stop here and you already know the answer. Well, I know the answer, but some of you may also, but let's not go there yet, okay? We'll go back to that, okay? But some question might be just, you're just given this matrix to begin with, and they might say, find the row reduced echelon form. In that case, you don't stop here and say, well, this is 0, then if you get the 0, then you can't do anything here, so you go to the next one, okay? You go to the next one and multiply by negative 1 over 12 to make this as 1, right? So you take negative 1/12 of R3, so you get 1, 0, negative 2, 5, 0, 1, 2, negative 1, 0, 0, 0, 1, okay? And then finally, this could be added to here, subtracted here, so R3, negative 5 could be added to R1, or R3 could simply be added to R2, replacing R2, and the result is that you get 1, 0, negative 2, this will be 0, 0, 1, 2, this will be 0, and you get 0, 0, 0, 1. So that will be your row reduced echelon form. Yes?
Sorry, it's a bit small. Is that R3 plus R2 equals?
Yeah, this is R3 plus R2. Alright, so that's the row reduced echelon form. But as I claimed, this already says something. Okay, so let's go back to this position here and try to see what it means. Okay, so what does that mean? First, 1, 0, negative 2, 5. What does that mean?
X1 is equal to 2 times X3.
No, let's just write it like this one. Okay, so it'll be 1 times x1 plus. I mean, you're right. What you just said is right, but let's just write it like that. Minus 2x3 equals to 5, right? That's what the top line says. Right? These are just coefficients, right? Where this is the other constant part on the right side. Right? So I just wrote down whatever that is. Okay? And then the next one is saying 0x1. Can you read it? I can't read it from here.
Plus x2 plus x3.
Just x2? Oh,
Yeah.
1x2.
1x2, sorry, plus 2x3 plus 0. I mean equals 0.
Equals negative 1. Okay.
Oh,
Alright. The last one?
Oh, okay, plus
0x1, 0x2, 0x3 equals to
negative 12.
negative 12. Okay. Alright, so that's That's what the equation is saying, and you already know that this doesn't have a solution. Why? Why is that?
We have 0 equals -12.
Because this last line says 0 equals to -12. Is that possible? Impossible. So the answer to this question is you have no solutions. No solution. Okay. Now, sometimes, because you've made something abstract and you're using a different gadget, you might not so trust it so much, right? You might be a little bit suspicious of what it's doing. So you can go back and think about that exact problem. Why is it that this system doesn't have a solution? Well, here's what happened. When I made this question, I made it so that it doesn't have an answer. Now, do you know how you can do that? Well, here's what I did. I took twice of this part, added to this one. So if I take double of this as 2x1 plus x1, what's that? 3x1, right? Twice of this one, there's no x2, so if you add, you're going to get this, right? And it's this, right? And therefore, these two equations imply that twice of 4 is 8, 8 plus 5, this should equal to positive 13. But I'm saying it has to equal to 1. So this equation has a contradiction to begin with. It's saying two different things. Okay. So if I take this times 2 and add to this second one, you get 3x1 minus 2x2 minus 2x3 equals to twice of 4 plus 5, that's 13. That directly contradicts this one. Okay? So of course, there's no way you can have a solution. Does it make sense? So you can easily make system of equations not to have a solution. Now, what if the question was exactly the same, but this was changed as 13? Well, what's going to happen if that's true? What do you think that's going to give you?
Infinite solution?
Hmm?
Or the infinite solutions?
Yeah, it will be infinite solutions. Why do you think that?
Because I guess you would just you could put any constant for like any value for x.
Yeah, okay, so I think you know where this is going. That's good. All right, so what's happening is that if this is 13, then suddenly you have infinitely many solutions because this last line, which seems to be giving you a new information, is not a new information. This is an outcome of the previous one, so that it's as if this third equation is good for nothing. So you erase it, and then you look at this system and think about what's given. How many unknowns do you have?
3.
3 unknowns, x1, x2, x3. How many equations do you have? Just 2. Is that enough to give us a solution? No. No, that's no good. Right? So that's going to be, so if that happens, it's like, let's just look at that one. If this is 13, then taking 3 times this 15 and subtracting here, it gives you -2. Okay? And then, is that right? -3. Oh, no, sorry. -3 of this plus this will give you a +1, right? Okay. And then you can see that this is just +1. When this is added to this, what do you get? You get 0. Okay. If that's what you have, then this is already row reduced echelon form. You can't do anything more because it's 0. What's reduced row echelon form? The leading term has to be 1, right? Or entire row has to be 0. Okay. Anytime you see a 1, there should be only non-zero number as 1. Everything else should be 0. Yeah. So that's already row reduced echelon form. And then if you write down what it means, this time, this last equation just simply becomes 0 equal to 0, and therefore you have infinitely many solutions. Okay? So here's another interesting part of this story, is that if you have more than one solutions, and if you do the reduced row echelon form, then you actually get a rather nice representation of the solutions, because here's what you have. This says x1 minus 2x3 equals to 5, and x2 plus 2x3 equals to negative 1. That's what you have, right? And because there is like 3 unknowns for 2 equations, there's like 1 dimension of solutions. Okay, so if you look at the solution inside R3, so if x1, x2, x3 is an entire space, right? The space. And in the space, if you collect all of the numbers that satisfy these 2 equations, well, do you know that one linear equation like this in the space is a... Do you remember that in vector calculus, right? This is a plane, so there's another plane. If you have 2 planes in space, and if you intersect them, what do you get?
1.
You get 1 line, right? You get 1 line, and so the solution has a dimension 1. It's like a line element has a dimension 1, right? A plane element has a dimension 2, and then space has dimension 3, and you can go further, right? So this is a one-dimensional space of solutions, and you can write down the generic solution by first setting x3 as t. So x3 is some arbitrary t, right? You plug that in, and you can solve for x1 and x2. So what do you get for x1? Plug in t, move it to the other side. What do you get? You get 2t plus 5, right? And then x2 is what? T goes here. Move it to the other side. What do you get? Negative 2t minus 1. Okay? So this actually has a solution. You can write down the solution set as x1, x2, x3 equals to 2t plus 5, negative 2t minus 1, and t. That's the generic solution to this system, this modified. So, sorry, I should really be presenting 2 different cases, but I got lazy, so we didn't have to calculate twice.
You said
yeah.
that's the generic solution?
That's the generic solution of this system, the one with 13. Yeah, and as I said, this gives you a line, right? You can imagine that in space, at time t equals to 0, there's a point at 5, negative 1, 0. And then as time progresses, it's moving along this line, right? When t is 1, you get 7, negative 3, 1. So it gets the next point, and every time t increases, this is a point that moves. What's the velocity of this? If you simply differentiate this, what do you get? You get 2, come on, you know how to differentiate. 2, negative 2, 1, right? So that's the direction that this line goes. Right? It's some direction, I don't know what, but it's a point that moves along the time. Okay. Some of you are still taking notes, so let me wait a little bit. Yeah, this is actually two questions. That's why. So I solved one with 1 here, and then the other question with 13 here. So it's really 2 questions. If it was 1, there's no solution. If it's 13, you have infinitely many solutions. And the solution space is one-dimensional. It's like a line. Yes?
On that top left part, if negative 2x to the subscript 2 was negative, wouldn't that get rid of the positive on the third row? So the circle part, circle bit on the top.
This
right?
one?
Yeah. So it says 3x1 minus 2x2. Should that negative 2x2 be a positive, or else it would just cancel?
Oh, you're right, you're right. Plus, thank you. Yeah, yeah, that's correct.